Hello guys, let's see differentiability. We already discussed about the continuity. Now we are going to discuss about the differentiability. But before starting differentiability, I'll say one thing, that if function is not continuous, then we should not talk about the differentiability. If the function is not continuous at any point, so we can say that function will not be differentiable. So we should not discuss about the differentiability. If the function is continuous, so when we can say that the function is, we can check the differentiability of a function. Now as you can see that, now we are going to talk about, in this you can see that there is diagram, so we are going to talk about the differentiability basically. See, this differentiability also has a similar concept like continuity. We have to check differentiability of a function, okay, existence of a differentiability, basically existence of a derivative at neighborhood point. That's why we have a left hand and right hand derivatives. So at any particular point, as you can see that this is the point A where we have to check. So at this point A we have to check about the differentiability. So definitely the neighborhood point of this A, we have to see what is the left hand side or right hand side. Okay, as we have done in continuity, that there was a point A, so we checked from here and we checked from here, from the left hand side, from the right hand side. At neighborhood points we checked. Similarly here we are going to check at neighborhood points, basically left hand derivative and right hand derivative. But here we are going to use a different formula. As you can see the curve, this is my curve, y is equal to f of x. Okay, now I'm taking one more point. See, whenever I have any curve, definitely from at this curve there can be many tangents, but at particular one point there can be a one tangent only. If I'm talking about this point A, so there will be only one tangent. If I'm talking this point, so there will be another tangent at this point only. But at this point, if this point A, at this point we cannot have any other tangent, we can have only one tangent. Similarly here at this point we have one tangent. So if you will draw tangent, different tangents, we have a line which is basically a secant, which is basically bisecting this intersecting this curve. So if I'll just move this line slowly, definitely it will come to the point where it will become a tangent. Same thing we have done here in this curve. So there was a line which I started moving slowly, so definitely at this point A, that line is tangent. You can see this is not denoted by the T. This T is nothing but a tangent, and this is making an angle phi with the horizontal axis. Now here we have one more angle which is basically made by the same line when it is moved slightly towards the right left, and it will intersect a point B. Okay, as you can see that the intersect the curve at point B. This is a point B where I can take the coordinates. If I have taken a coordinates of the point A as A and A comma f of A, so similarly I am taking here coordinates of point as A plus H comma f of A plus H. Okay, so why? Because it is just, we are taking the, it is B is nothing but we can say the point, and H is a parameter, so H distance is moved, okay, when we are intersecting there. Now what will happen here is, in this case, as you can see that if the point B is A plus H and f of A plus H, so the distance, the vertical distance is here f of A plus H minus f of A. Till point A I'm talking about. Till this line it will be f of A plus H only. So this is totally vertical distance. And now we'll talk about the horizontal distance. Since we know this, till this point the distance is A plus H, and till A point distance is A. So if I subtract this, I'm gonna get this distance, which is, I mentioned here, this is f of A minus f of A plus H. So first, this is just explanation of diagram. Now we know every part of this, okay, diagram. Now we'll move forward, how the differentiability will act here, how it will work out. So when we talk about the right hand derivative, again we have to use the limits here. So when we talk about right hand derivative, we can say, we can represent by the positive, like A positive, as you can say that f dash of A positive. So this is a common formula for the derivative which we have to use it to find out the derivative, or check the derivative, or check the existence of a derivative of a function. So f dash of A positive for the right hand derivative, f dash of A negative for the left hand derivative. So this formula, limit h tends to A 0 positive, f of A plus H minus f of A divided by H. This came nothing but from the diagram only. As you can see that we have here f of a plus h minus f of a, and here in denominator, that see that basically this angle, when I say that this angle we are talking about, so this angle, what is this angle? Basically nothing but y by x. Same thing I am doing as slope. If you little bit have a knowledge about the differentiation, the slope, so slope, what happens in the slope is slope of a curve, any curve slope is measured by the slope of a tangent with respect of the horizontal axis. So this theta is nothing but a slope of a curve, or it can be known as tan theta, it can be m, it can be, representations are different. That is nothing but one more thing, we have dy by dx. A slope is always represented by dy by dx, and what is dy by dx? It is nothing but my derivative. Same thing from this diagram, what is my dy by dx, which is nothing but f of a plus h minus f of a divided by h. So as you can see here, I've written f of a plus h minus f of a divided by h. Why I'm using the limits? Because to say that, to check the existence of a f, just that the formula is enough to find the derivative, but I'm checking first existence of derivative. That's why I'm using the limit. So if h will approach at that particular point, because h is a small parameter, so what will happen to the my derivative? So this is my this is nothing but my right hand derivative, and from the diagram we can find out, this y by x is nothing but equal to tan phi, because this is nothing but equal to phi. So this is phi. So we are finding about this theta only. Theta means this phi only, this angle only basically, or tan phi. Tan phi means slope of a curve. Here we can mention it as slope of curve or slope of tangent. Okay. So that's why I mentioned here as tan phi or tan psi, both are same here in our case. Now, when I talk about the left hand derivative, so it will be represented by f of a negative here. A negative, limit h tends to 0, f of a minus h minus of f of a divided by minus h. This is also from the diagram only. And yes, the same thing, basically derivative we are getting for the lower point. If I'll talk about here, for the lower point, you can see that for the b point already we found out as f of a plus h minus f of a. We have a lower point a at this point, also we can find out the same left hand derivative. This is the common point. Okay, so we can find this side and this side. Upper means upper, not upper, we'll say right of this side will right hand side, left will be left hand side. So like that we can find out the derivative. So if these two derivatives are equal, then we can say that my derivative for that particular function exists. That is the here existence of derivative. Okay guys, so what will happen there is, as we said, so you understood completely the curve. Now from the curve, again the final definition, I can say that at point A my function will be differentiable for the both f dash a positive, which is nothing but limit h tends to 0, f of a plus h minus f of a divided by h, and f dash of a negative, limit h tends to 0, f of a minus h minus of f of a divided by minus h. So when these limits, these derivatives, basically f dash of a positive and f dash of a negative are equal, so we can say that at point A my function f of x will be differentiable. So my function is differentiable at A, means we can say that x tends x equal to a at this point.